Okay, so in your notes, we're going to go over objective number 3. I can define tides and explain what is the force that controls them. So, a tide is a fluctuation in the sea level along the shoreline. And looking at this picture, what do you think the force is that controls them? Write it down. All right, if you're looking at the picture, it's the moon. This should have been one thing that you probably rated yourself high on the pre-post. All right, objective 4 says, I know how much time is between a high and a low tide. This image is off of page 66 in your book. Looking at this image, this is going to be what we call a semi-diurnal tide, where there are 2 highs and 2 lows within a day. Not everywhere on the earth has this. We do. And so what you're looking at here is a high tide here and a low tide here. There is a 6-hour difference between those tides. But something else to point out is you see a low tide here and a low tide here. There is actually 12 hours and 25 minutes in between the 2 highs and in between the 2 lows, and there's 6 hours and 12 minutes in between a high and a low. Objective 5 says that you can explain how the tide is going to expose different communities in an estuary. What I want you to look over here is the difference between a high tide and a low tide. The diagram on the top is high tide, and the diagram on the bottom is low tide. I want you to write down one difference that you see in between the videos, or in between the 2 pictures. So pause this video and write down the differences that you see. Alright, now that you have some things written down, you should have noticed a couple things besides just the water level being lower. The water level is definitely higher up here than it is down here, so you should have had that high tide has a higher volume of water. But you also should have seen exposure. These little black dots represent crustaceans and crabs, things that can be exposed, not fish. And if you look, they are surviving exposure in the mud flaps during a low tide. I also want you to notice one other thing, that the water level and the cordgrass where they start kind of aligns. Okay, a lot of the salt marsh plants can have some exposure, and some they can be exposed, but they can also be submerged throughout the day as well. Okay, so standard 6 is going over the difference between spring tides and neap tides. This is the diagram in your book. One thing I want you to note, I'm not going to make you understand the different types of moons, but I do want you to notice that a new moon and a full moon is when you don't see the moon at all or you see the full moon itself, versus the half moons, which is the first quarter and the third quarter moons. The more of the moon you see or don't see, the stronger the force. That's one thing I want you to know. Whereas if you have these half moons, the force of the moon becomes weaker. That's one difference that I want you to note. I also want you to know where the Earth is in relation to the moon and the sun. When you look at a spring tide, you have the moon either directly in between the sun and the Earth, or you have the moon on the opposite side of the Earth and the sun, but they're in a lateral line. And that's something you need to know. Spring tide is a lateral line. But how does it affect the tides? In a spring tide, you have your highest highs and you have your lowest lows. And what that means is your high tide is going to come more on land than it does at any other moon, but your low tide is going to go further out to sea, like instead of compared to any other low. A neap tide has generally the same, there's little differences between a high and a low. So that's where you're not going to see a huge distinction between a high tide and a low tide. So spring tides are bringing the most volume on Earth. Sandy actually was, Hurricane Sandy actually came during a spring tide, which is why the tidal surge and the storm surge happened at the same time in our area, which is why it was a little more catastrophic. All right, this is Danielle's YouTube video she found for her online resource, so great job, Danielle. And I like this video. If you want to listen to it itself, it's on the handout underneath the objective. It's right there, Danielle's video on tides. But what I'm just going to kind of show you is I want you to kind of follow the moon. Okay, I'm going to kind of go through this step by step myself, but what I want you to see as I pause certain things, right here, when that moon gets in between the sun and the earth, you see that tidal bulge really pull. The earth has a great, the moon has a great gravitational pull towards the water. They have an attraction to each other. So what I want you to see over here, this is what we're talking about. This would be a spring tide. You have a highest high tide over here, and then over here you're going to have a really low tide, the lowest of the lows. Okay, but then when the moon becomes perpendicular, so I'm going to scroll down right here. Hold on, not quite. When it becomes perpendicular with the sun, that is when you're going to have a neap tide, and you're going to see that bulge kind of go down and spread itself out and become more even around the earth itself. Okay, this is another video to help you understand the tides. This animation was brought to you by Lana, and you can have the hyperlink underneath Objective 3 on the pre-post sheet. So going back to the objective, this just kind of reviews what we've been talking about. Watch the moon. The moon is a circle. As it moves, the tides are going to change. The difference between the yellow and the pink is that the solar tides is the attraction of the earth to the sun, whereas the lunar tide is what is being pulled by the moon. And so what you're looking at, what I want you to notice from this animation is, look, spring tide, line. Neap tide, perpendicular. Spring tide, line. Neap tide, perpendicular. I like this animation to kind of show you the difference between those two. Okay, our last objective, number 7, defining semidiurnal, mixed semidiurnal, and diurnal, and list locations on Earth that experience those tides. Well, I want you to look at this graph that is found on page 67 in your book. And just by looking at these 3 different charts here, I want to start with diurnal. Di means 2. And so what that means is you only have 2 tides a day. You have 1 high and 1 low in a 24-hour period. So diurnal is defined as 1 high and 1 low. You predominantly find diurnal tides really high altitudes. So if you look at this, which is also in that book, diurnal is the red, and you find them really high altitudes is where you usually find them, but you can find them in other places on the earth. Mixed semidiurnal and semidiurnal both have 2 highs and 2 lows. A semidiurnal is really concentrated around the equator, and that's where the highs and lows are generally the same for the day. The mixed semidiurnal means that you're going to have a high tide and a low tide, but the 2 highs are going to be different in length. So for example, right around hour 6 or 7, you had a high tide, but it was a lot lower than the high tide that was at hour 18. Going back to the chart, you can kind of see them on different coasts. The Pacific coast has a lot of the mixed semidiurnals, whereas our coast, the Atlantic coast, has more of a semidiurnal. We are definitely a semidiurnal tide area. All right, this is the website that Eric found that goes over objective number 7. So his link is actually found underneath objective number 7. What I want you to note is that this is what a diurnal, this is a different graph, different than the one in your book. Sometimes it's nice to see something different. So what you're looking at in a 24-hour period is 1 low tide and 1 high tide. What you're looking at in a semidiurnal, and that's where we are, is 2 high tides and 2 low tides. What you're looking at in a mixed is 2 lows and 2 highs, but they're not even. So 1 high tide is going to be bigger than the other, and 1 low tide is going to be lower than the other.